The ultimate goal of our laboratory is to uncover genetic regulators, such as microRNAs, that are contributing to ovarian cancer initiation, progression, and tumor recurrence, with the goal of discovering novel predictive biomarkers or drug targets that could ultimately benefit patients.
We're very interested in looking at normal to tumor transition. So now we could actually determine at what point in that normal to tumor transition does this microRNA that we're interested in get turned on. Then that would be a way to detect these women at a very, very early stage. If we show certain microRNAs are highly expressed in patients that tend to do really poorly, and that these microRNAs are targeting signaling pathways that we know are detrimental to the cell, can we target these microRNAs? That's where we need to know the basic biology of how these microRNAs are processed.
Our laboratory's mission is really to understand what drives lethal human prostate cancer. And we specifically focus on transcriptional regulation and epigenetics to understand more about how RNAs are turned on and off, and how that process impacts resistance to therapy and also tumor progression. And the model we focus on specifically is advanced prostate cancer. A physician scientist, I'm a medical doctor. I still see patients a half day a week. I have the privilege of doing that, and it really informs every facet of what we study in the laboratory. So we can ultimately get to therapies that we move back to clinical trials so we can improve the quality and quantity of life for patients. So I really view patients as our allies in all the research that we do.
It was a fortunate situation where I had a mentor who was allowing me to be somewhat independent and explore my passion of pursuing a field that I knew I was personally affected by and wanted to continue working on, looking at the genetics of ovarian cancer.
The welcomeness of people and the passion people have for excellence at U of M. And I think that really comes down to the fact that so many of us are interested in trying to move the needle on the fields that we're studying with the ultimate goal of trying to help mankind.
One of the major reasons I came to U of M was to work with talented RNA biologists and utilize the clinical samples that we've been able to collect over the years to see if we can interrogate what are the most relevant microRNAs in ovarian cancer biology.
That I interviewed at U of M, I was really struck by not only the excitement of people's research programs, but how down-to-earth people were, their willingness to collaborate, and the collegiality. And I've been at, I believe, 5 medical institutions now and scientific institutions as part of my training. And I've never been at a place like U of M, which is really such an open place, even though it's such a large research university. So I was blown away even to determine that there was a center for RNA biomedicine. And I think there are very few universities that have such a center. We find ways to collaborate and tackle some very important problems.
We have a very strong group here who already is very collaborative and works with many people across the globe. So we're working together with so many different groups to see if we can build that cohort.
I think it's really the opportunity to interact with people for whom you may not have a preconceived notion that they would be a great collaborator or intersect with your work. That's really where I've found some of the best discoveries and the best collaborations that I've had.
Is the number of resources that are made available to scientists that are interested in exploring RNA biology, such as the BRUCE core, and we're able to assess what are the nascent RNAs that are relevant in these models using BRUCE.
We really try to focus on the unanswered and most important clinical dilemmas we face in taking care of patients.
It's all based on a small microRNA, right? So I always say these guys are small but mighty.